1.5 million years ago, something walked across wet mud on a lakeshore. Then, within hours, maybe less, something else walked across the exact same mud. It wasn't the same kind of creature, not an animal and a human. Two different species of upright, walking, footprint-leaving relatives of ours, both crossing the same patch of ground, so close together in time that the mud hadn't even dried between them. This isn't a theory. It isn't a guess based on old bones found miles apart. This is physical, direct, undeniable proof, footprints preserved by accident, rediscovered by scientists nearly 50 years after they were first noticed. The site is called Kubifora on the shores of Lake Turkana. And what researchers found there didn't just prove two species crossed paths. It rewrote what we thought we knew about how one of them actually looked, moved, and lived. So who were these two? What were they doing on the same lakeshore? And why does one single trackway of footprints matter more than almost any bone ever found? 3 real answers, all written directly into the mud. The first species is one you're already related to. Homo erectus. Taller, more efficient walkers, bigger brains than anything that came before them, and a direct link in the chain that eventually leads to us. The second is stranger and far less famous. Paranthropus boisei, sometimes nicknamed Nutcracker Man for its massive jaw and teeth. Not a direct ancestor, a cousin. A different branch entirely that walked upright just like we did, but never survived to see this era end. For decades, scientists assumed these two species mostly avoided each other, living in slightly different habitats, eating slightly different foods, crossing paths rarely, if at all. The footprints at Kubifora say otherwise. The footprints themselves were first noticed decades ago by geologist K. Behrensmeyer of the Smithsonian. But the technology to properly read what they meant didn't exist yet. It took until 2026 and a team led by researcher Kevin Hatala using modern 3D scanning to finally read the full story preserved in that mud nearly half a century after it was first uncovered. The study was published in the Proceedings of the National Academy of Sciences, one of the most rigorously reviewed scientific journals in the world. This wasn't a guess. It was a conclusion the evidence forced them to. So how do you prove two different species were in the same place within hours of each other, using nothing but footprints? The answer is in how mud behaves and how quickly it stops behaving that way. Wet lakeshore mud only holds a clean, detailed footprint for a narrow window, hours, sometimes a day or two, before it dries, cracks, or gets washed over by the next layer of sediment. Both sets of prints at Kubifora show that same sharp, undried, unweathered detail, which means both species walked through while the mud was still fresh. Not years apart, not seasons apart, the same narrow window of time. This wasn't even the only trackway found nearby. A second, slightly older set of prints in the same region also showed both species together, meaning this wasn't a one-time accident. These two species shared this habitat for a very long time. Now, here's the detail that genuinely surprised the researchers. This wasn't just proof of two species sharing space. It was proof that one of them, Paranthropus boisei, was nothing like what scientists had assumed. Based on a handful of rare bone fragments found over the decades, most researchers assumed boisei was considerably smaller than Homo erectus. Shorter, lighter, easier to picture as the smaller, weaker cousin. The footprints told a completely different story. Some of the largest boisei prints belonged to individuals standing nearly 6 feet tall and weighing around 165 pounds. Nowhere near small, close to Homo erectus in size. Bone fragments are rare, scattered, and easy to misjudge. A single well-preserved trackway, showing real weight-bearing prints from real living individuals, turned out to be more reliable than decades of fragmentary bone evidence. It's worth understanding exactly how a footprint reveals a body size because the method itself is remarkable. It isn't just measuring the length of the print. It's physics applied to mud. Researchers measure how deep a print sinks into the mud, the exact shape of the pressure pattern left by the heel and toes, and the spacing between one step and the next, called stride length. Combined, those measurements let researchers calculate body weight, walking speed, and even whether an individual was walking casually or moving with urgency, all from a single footprint that lasted less than 2 days before the mud dried around it. This same technique is what confirmed the boisei prints belonged to a walking gait strikingly similar to modern humans, not the slower, more primitive shuffle some scientists had assumed for a species with such a different skull and jaw. There's a second discovery hiding in the same mud, and it might be even more important than the size reveal. The boisei trackway wasn't from one individual, it was from a group. At least 8 of them moving together. That's direct evidence of social behavior. A species long assumed to be simpler and more solitary than Homo erectus was actually moving in coordinated groups along the same lakeshore at the same time as us. Group movement like this usually points to real social structure, protection in numbers, shared foraging, possibly even coordinated care of the young and old, not the isolated, simple-minded picture this species was given for decades. Researchers also compared the footprint pattern to modern chimpanzee and gorilla group movement and to modern human group movement to see which one it more closely resembled. The spacing and coordination lined up far more closely with how humans move in a group than with any great ape. That single comparison quietly moves Base closer to us behaviorally than to any ape alive today. A species usually reduced to a strange jaw and a few scattered bones turns out to have walked, and likely lived, in a way that would look recognizably familiar. So here's the question the whole video has been building toward. Did they actually see each other? Did a Homo erectus and a Boise ever stand face to face on that same lakeshore? The honest answer is we can't know for certain. The footprints prove they were in the same place within a very narrow window, but not that they were there at the exact same moment, or that they ever laid eyes on one another, but hours apart on the same open lakeshore, with no dense forest to hide in, makes it very likely that at some point, in some form, these two species were aware of each other's presence. Two species, walking upright, using tools in at least one case, aware of a very different kind of creature sharing their world. Not a predator, not obviously prey. Just another way of being human-shaped, going about its own life nearby. It's worth being honest about how this story ends because most retellings skip it. Homo erectus survived, spread across 3 continents, eventually gave rise to us. Paranthropus boise did not. Boise vanishes from the fossil record roughly 1.2 million years ago. Nobody knows exactly why. Climate change, food competition, and pressure from more adaptable relatives are all real possibilities, but no single cause has been proven. One real clue sits in that massive jaw the species was nicknamed for. Boise's teeth and jaw muscles were built for grinding tough, fibrous plant material, roots, nuts, coarse vegetation, food that took real mechanical effort to break down. That specialization was a real advantage when tough plant food was reliably available, but it also meant Boise's whole body was built around one narrow survival strategy, while Homo erectus was already using tools and likely fire to unlock a much wider range of food. When the climate shifted and that specific food source became less reliable, Boise had far less room to adapt. Erectus, already flexible, already resourceful, simply had more options left when the world changed underneath both of them. Every trace of that entire species, the tools, the group behavior, the massive jaw built for grinding tough food, all of it is gone except for bones scattered across a handful of sites. And now, these footprints. Here's where it connects directly to how science works today. This entire discovery almost didn't happen a second time. The footprints were sitting in the research record for nearly 50 years before the right technology and the right team came together. That's a real, sobering thought. There may be dozens of discoveries like this one, already sitting in museum drawers and old field notes, just waiting for the right question or the right tool to finally reveal what they've been holding on to the whole time. So go back to that lakeshore, 1.5 million years ago. 2 species walking the same mud hours apart. One of them became every human alive today. The other became a set of footprints and not much else. For one brief, muddy afternoon, both of their stories were still being written side by side. Neither one knew how it would end. Neither one could have known that a footprint would outlast almost everything else they ever were. They didn't have a word for extinction, or evolution, or ancestry. They just kept walking, together and apart, across the same mud on the same morning, 1.5 million years before anyone would ever think to ask who they were.